Good evening, children. Good evening, children. Good
evening, ma'am.
evening. Good evening, ma'am.
Good evening, ma'am.
Good evening. Good evening. Fine. We'll have to continue with this question. We finished till question number 5. We did this in the last class. You can take a screenshot of this slide, children. You work this in your book. Just take a screenshot and yeah. Yes. Okay, so here a milk tank is in the form of a cylinder whose radius is 1.5 meters and length 7 meters. So you can see the cylindrical tank, radius 1.5 meters, length meaning height 7 meters. Find the quantity of milk in liters. Quantity of milk meaning the capacity of the tank. Find the quantity of milk in liters that can be stored in the tank. What is the capacity of the tank is the question. Find the quantity of milk in liters. When you find the capacity, you will get the answer in meter cubed. Meter cubed, because the radius and height are given in meters. So you will get the capacity of the cylindrical tank in meter cubed. You just have to convert that to liters using the relationship between meter cubed and liters. I hope that's clear.
Yes, ma'am.
Yeah. So what is the formula to find the capacity of a cylinder? Class, please respond. What is the formula to find the capacity?
Ma'am, volume.
Yeah.
Ma'am, volume, ma'am.
Yeah, volume. What's the formula?
Pi
Yes.
squared h.
Pi r square h. So the value of r and h is given to us in the question, and you will get the volume or the capacity in meter cubed because the radius and height are in meters. So we need to convert this to liters. The relationship goes like this. 1 meter cubed is equal to 1,000 liters, or you can say 1 meter cubed is equal to 1 kiloliter. 1 meter cubed is equal to 1,000 liters. And you know 1 kilo means 1,000, 1 kilo. So instead of saying 1,000, you can also say 1 kiloliter. 1 kiloliter. Both are the same, children. They are not different. Both are the same. You can say 1 meter cubed is 1,000 liters or 1 meter cubed is 1 kiloliter. Have we seen these earlier?
No, ma'am.
No. Okay, then I need to explain. Okay. So what is this? How do we understand? What is this? What is the meaning of this relationship? 1 meter cubed is equal to 1,000 liters. How do we understand this? So you imagine a cubical tank whose edge is 1 meter. Imagine a cubical tank whose edge is 1 meter. What will be the volume of this tank, or what will be the capacity of this tank? What will be the capacity of a cubical tank whose edge is 1 meter? What is 1 meter equal to? 100 centimeters, right?
Yes, ma'am.
Yeah, 100 centimeters is 1 meter. So you can imagine what 1 meter is, 100 centimeters. And what is 100 centimeters? Think of your scale. The scale which fits into your pencil box is of length 15 centimeters. So kind of 6.5 times that scale is 1 meter. 15 centimeters is the length of the scale which fits into your pouch, your pencil pouch or your pencil box. You have a longer scale. 30 centimeter scale also there you have, but the small one, you can imagine with that also, anything. So 15 centimeters taken 6 times is 90 centimeters and a little more than that. So kind of 6.5 times your scale is 1 meter. So that length, 1 meter. Just visualize that. That's what I'm asking you to do. 15, 15, 15, 15, 6 times and a little more is 1 meter. Because 1 meter is 100 centimeters. Okay, so you all have the picture of a cubical tank whose edge is 100 centimeters or 1 meter. What is the capacity of this tank? How do you find the volume of a tank or capacity of a tank? No, we cannot be silent. We have come to the end of this lesson. Yes, Keetana, Devadarshini, Raja, because only you three are in the meeting.
Yes, ma'am.
Yes, please. What is the formula to find the capacity of a cube?
A cube, ma'am.
A cube. A cube. Now, in our example, what is the value of A? Raja, Devadarshini, what is the value of A in our example? Okay, Keetana, what's the value of A in our example?
Ma'am, I cannot see the screen, ma'am. Like only the meeting screen.
No, I told you. Okay, no problem. Now,
one, ma'am.
1. So what will be the volume or the capacity of the cubical tank whose edge is 1 meter?
It will be 1 meter cube.
Because 1 into 1 into 1 is 1 meter cube. So volume of a cubical tank of edge of, oh my God, of edge 1 meter is 1 meter cubed. Volume of a cubical tank or capacity of a cubical tank whose edge is 1 meter is 1 meter cubed. Yes or no?
Yes, ma'am.
Okay, now this tank, the volume of this tank is 1 meter cubed. That means it can hold 1,000 liters of liquid. If you have a tank whose edge, if you have a cubical tank whose edge is 1 meter, then the capacity of the tank is 1 meter into 1 meter into 1 meter, which is 1 meter cubed. Now this tank can hold 1,000 liters of water or 1,000 liters of liquid. Is the meaning of this relationship. Is the meaning of this relationship 1 meter cubed is equal to 1,000 liters. That is, if so, now the vessel need not be cubical always. It's easy to find. See, now to get the volume equal to 1 meter cube is easy with a cubical tank, because if you assume the edge of the cubical tank to be 1 meter, then the volume is 1 meter cube. Now it need not be a cubical vessel or a cubical tank. It can be any vessel whose volume is 1 meter cubed. So for some value of radius and height, for some value of for some values of radius and height, the volume of a cylinder can be 1 meter cubed. The volume of a cuboid can be, for some values, the volume of a cuboid can be 1 meter cubed. The volume of a cone can be 1 meter cubed. So I have taken the example of a cube just to get that capacity of 1 meter cubed easily. So the vessel need not be cubical. It can be cylindrical, it can be conical, whatever, cuboidal, cylindrical. If the capacity of that vessel is 1 meter cubed, why 1 meter cube? Because you will have the values in centimeter or meter. So you will get the capacity in meter cubed or centimeter cubed. So you can convert that to meter cubed. If the capacity of a vessel is 1 meter cubed, it means it can hold 1,000 liters of liquid. Children, do we get that clearly?
Yes, ma'am.
What about Kirtana and Devadarshini?
Yes, ma'am.
Okay. Who can repeat this? One of you explain. Okay, let me, yeah, yes, Rajan, yes.
Ma'am, we have seen that if 1 meter cube, if the volume of a cubical tank is 1 meter cube, then the capacity of the tank, the capacity of the liquid that the tank can hold will be 1,000 liters or 1 kiloliter.
Very good, very good. Is it necessary that the container should be cubical?
Yes, ma'am.
No, ma'am, it can be any vessel, you said.
It can be, the container can be of any shape, but its capacity should be
1 meter cube.
Meter,
Sorry.
ma'am.
1 meter
Meter.
cube. 1 meter cube.
Yes,
Capacity has to be 1 meter cube.
Yes.
The vessel, the vessel can be a cylindrical vessel. It can be a conical vessel. It can be a spherical vessel. It can be a hemispherical vessel. It can be cylindrical, cuboidal, whatnot. Whatever be it. If it's volume is if when liquid is filled to the brim. So we say capacity. Capacity is the maximum volume the container can hold. So if the capacity of the vessel is 1 meter cube, that means that vessel can hold 1,000 liters of liquid. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, now look at the answer. So we'll first find the capacity of the tank using the values of R and H. You can see it here. Please work this and you will get the capacity in meter cube because the radius and height are in meters. Now see the conversion. 1 meter cube is 1,000 liters. 49.5 meter cube is how many liters? Isn't it easy to convert? Please acknowledge, class.
Yes, ma'am.
I'll repeat. Now, this is the standard relationship. This is the standard relationship. This is a proportion. If it's an argument here, it's an argument here. If 1 meter cube is 1,000 liters, then 49.5 meter cube is how many liters? See if this is the right side, oh sorry, the left side of the proportion. This is the left side of the proportion. This is the right side. See the order. The first term meter cube. Here also the first term should be meter cube. Here liters, here liters. Or you can write it like this also. 1,000 liters is 1 meter cube. Then how many liters is 49.5 meter cube? Do we understand how to, put the argument in a proportion?
Ma'am, I can understand this argument, but I have a small doubt, ma'am.
Yeah.
Ma'am, we have in this slide you have written as 1 meter cube is 1,000 liters, and this side you have written 49.5 meter cube is X liters.
Yeah, because we don't know how many liters. We are going to find that. Correct.
Yes,
Yeah. Yeah.
but
Continue.
But is this 1 meter cube is 1,000 liters? Is that a formula, or we are writing that as a part of this?
That's the general relationship. No, 1 meter cube is 1,000 liters is the general relationship. Now we are finding it specifically for 49.5 meter cube using this general relationship.
Yes, ma'am.
Can anyone tell me? No, maybe. Okay, let me finish this, Raja. You can come back with your question. Maybe when you ask me again, I'll understand. 1 minute. Let me just finish with this. So this is the standard one. And this is, we're trying to find how many liters is 49.5 meter cube. So now, you know, product of extremes is equal to product of means. Product of extremes. So 1 into x is equal to product of means is equal to 49.5 into 1,000 or 1,000 into 49.5. So on working this, we get 49.5 into 1,000. 49.5 into 1,000 is 49,500. Isn't it's not 45? Have I worked this correctly? I've missed the decimal point. No, done correctly. Yeah, so 49,500 liters. So that means the capacity of the milk tank, is 49,500 liters. It's like doing. So we say 1 kg is 500 rupees. So say like 25 kgs is how many rupees? So this can be written as a proportion. 1 kg, 500 rupees. 25 kgs is X rupees. And you can work this as a you can use the rule product of extremes is equal to product of means and find the cost of 25 kgs. Whenever you know, it's like when you know that for a unit it is something, you can find for a different value. Like for a unit, 1 kg is 500 rupees. 25 kgs is how many rupees? Raju, just come back with your question. Okay. Have you come across proportion in your school in the chapter ratio and proportion?
No, ma'am. They haven't started the chapter yet.
Now I understand it. Okay.
Actually, they have shortened some portions due to this law.
Okay. Okay.
Half portion is has not.
At the end of the class, no? At the end of the class. Yeah, tell me.
Almost half the portion is not teaching.
You just shared the list of chapters which have been completed in your school so far, okay?
Yes, ma'am.
I think all of us can do that. The chapters that have been covered in your school so far.
Okay, ma'am.
Yeah.
So first I got a doubt that
Yeah. No, now I understand what your doubt is. So because we are not aware of what a proportion is. Yeah. What about Keertana and Devadarshini?
Ma'am, I have studied it
Yes,
in
ma'am.
earlier
I
classes.
studied
ma'am.
in 6th itself, ma'am.
Yeah, ma'am. But not in 8th grade.
Okay. Fine.
For 7th, I don't remember, ma'am. For 8th, they didn't teach about proportion and ratio, but for 6th, they have done, ma'am.
Okay, fine. All right. So now it's not called ratio and proportion for you. For 8th standard, it is, I think it will come under the group heading comparing quantities where you have inverse proportion and direct proportion. You learn many chapters under the heading comparing quantities, ratio, proportion, some business maths and all that. So ratio proportion is of 6th and 7th standard. But I should tell you now, so this is when two ratios are equal, where are you, Raja? Yes. When two ratios are equal, they are said to be in proportion, Raja. When
Yes.
two ratios are equal, they are said to be in proportion. That means, and let me tell you, see here. Now if say one pencil or okay, one pencil costs 25 rupees. What will be the cost of 4 pencils? 100 rupees. 100 rupees. See the ratio, pencil by cost, one pencil 25 rupees, 4 pencils 100 rupees. See that the ratio will be the same, 4 ones are 425 times. The ratio is the same. 1:25 is the same as 4:100.
Yes, ma'am.
One pencil, 25 rupees. This ratio and this ratio, 4 pencils, 100 rupees. This ratio is the same. So when the equality of two ratios, when two ratios are equal, they're said to be in proportion. And when we call this a proportion, it means this ratio 1/1000 should be equal to the ratio 49.5 by x. It should be equal. See, I've given you a different example. One pencil, 25 rupees. And you know 4 pencils will be 100 rupees. They will be the same, they'll have the same ratio, 1/25, 1/25. 4/100 is also 1/25. Similarly, here the ratio will be the same. 1/1000, the ratio 1/1000 will be equal to this ratio 49.5 by x. You can also work it like that. See it, you can also do this like this. 1 meter cube, 1000 liters is equal to 49.5 meter cubed x liters. The ratio is the same. This ratio and this ratio will be the same. And here what we do, we cross multiply. No, x is equal to 1000 into 49.5. Same thing you get. See here, let me do it again. See here, 1 meter cube, 1000 liters. This ratio should be equal to this ratio. 49.5 meter cube, how many liters? So x into 1 is x is equal to 49.5 into 1000. So x into 1 is equal to 49.5 into 1000. So x is equal to 49,500 liters. You can also write it like this. It can be presented like this also. I repeat, you can also write it. See, this step can be presented, this step, because is2 means division only. Is2 means division. See, when we say 2:5, it means 2/5. 1 meter cube is 1000 liters. So 1 meter cube by 1000 liters, this ratio will be the same as the ratio 49.5 meter cube x liters. So on cross multiplying, you will get x into 1 is x, 1000 into 49.5, 1000 into 49.5. So x is 49,500 liters.
Yes, ma'am. Now I can understand.
Yeah, instead of this by is what is to here. This by is to here. And this is as to, this is as to. And this is another ratio. That's what you see. See, this is to means division. You can do it like this also. You can also write it like this. You can also write it like this. Here cross multiply and get the answer. When you write it as a proportion, like this, we say product of extremes. Product of extremes, that is these terms, these are the extremes. Product of extremes, 1 into x is equal to product of means, These are the terms in the mean position. These are the terms in the extreme position. These are the terms in the mean position. So product of extremes is equal to product of means. All right. Class, so this is how we convert meter cube to liters. Is that fine, children?
Yes, ma'am.
Okay. Yeah, please write down. Please work this, children. Done, children?
No, ma'am.
Finished, ma'am. I finished.
Okay. Done? Raja?
Yes, ma'am.
Okay. Next one. So at this point, I must say that in our classes, we have completed all the important chapters that are needed, for your that form the basics for your 9th and 10th. With volumes and surface areas, we have done all the important chapters you need for 9th and 10th. So that comparing quantities where you have simple interest, compound, simple interest, no, that's of 7th standard. Compound interest, direct and inverse proportions. I'm not saying they're not important. I'm not saying they're not important, but the absence of that knowledge will not affect your 9th and 10th portions. The understanding of your 9th and 10th portions. That's all I can say. Everything is knowledge, but the absence of that knowledge will not affect your understanding of the portions of 9th and 10th. That much I can promise. So we have touched on all the, we've done the other important chapters like algebraic identities, factorization, whatever we have covered, the knowledge of square roots, cube roots. Well, I'm not able to get the chapters. So volumes and surface area, what we're doing now. Yeah. Yes, children. So this question, if each edge, have you got your timetable for the final exam?
Yes,
Ma'am,
ma'am.
for me, final exam itself got completed.
When did you finish?
Ma'am, today only, ma'am.
Today you finished.
Yes,
Can you share your maths question paper later at the end of the class?
okay. Okay, ma'am.
Yeah, okay. Kirtana and Raja?
Yeah, ma'am. It's gonna start for me in 16th, from 16th to 25th.
16 to 21st, is it?
16th to 25th, ma'am.
2-5. Okay.
Yeah, ma'am.
What about Raja?
Ma'am, they are starting on 17th, I think so, ma'am, and they entered 30th of this month.
Oh, okay.
Because they
Yeah, so
give.
even I was thinking that mostly this should be the last class for the 8th standard because you will be starting off with your final exams. That's why I asked you also. Okay, fine. So I think Tuesday is 15th, right? March 15th. Okay, fine. All right, children. So I'll be scheduling. You share your portions with me. That will be useful for me to schedule the exams in the portal.
Okay, ma'am.
Share your timetable as well as your portions. First, share the list of chapters that has been covered in your school, and then if you have all the chapters for the exam, fine. Otherwise, if you have a part of it for the final exam, just let me know that also.
Okay, ma'am.
Share your timetable. Then a list of chapters, the list of chapters that have been covered in your school and your portions for the exam. All right. So this question, if each edge of a cube is doubled, okay, so edge normally we say A. So if it is 2A, how many times will its surface area increase? How many times will its volume increase? Okay, so cube. So let the original edge be let the original edge of the cube be A units. So what's the original volume? The original volume is A cubed cubic units. What's the new edge? The new edge is it's doubled. So 2A units. 2A units. So the new volume will be, what is the new edge? 2A, right? Whatever is the edge cubed. So the new volume is 8A cubed cubic units. Let's see it again. Original edge of the cube, A units. Original edge of the cube, A units. Original volume, A cube, cubic units. New edge, doubled, so 2A units. New volume is whatever is a new edge cubed. So 8A cubed. See, if you write like this, you're wrong. Edge cubed like this, you're wrong. It's not 2A cubed, it's 2A the whole cube. Whatever is the edge should be cubed. 2A is the edge, 2A is the edge. That entire thing should be, okay, see here, edge cubed it is. What is the edge 2A? So that makes it 8A cubed. Now you should not put the bracket. Again, it will become 8A the whole cube. So original edge A, original volume. See, we're talking about a cube, A cube. New edge 2A. Are you all looking at the screen? New volume.
Yes.
2A the whole cube. Yeah. Which is 8A cube. Now what do you see? What is the original volume? A cube. It's become 8 times A cube now. See, original volume is A cube. Now the new volume is 8 times A cube because 8 into A cube, no? 8A cube means 8 into A cube. So it's now 8 times A cube. So how many times? I think I've answered the second question first. Okay. I've answered the second one. So how many times will its volume increase? Its volume will increase 8 times. 8 times. How many times? 8 times. Now the surface area. What is the original surface area? Original surface area is, what's the formula to find the surface area of a cube? What is the formula to find the surface area of a cube? Surface area meaning total surface area.
Ma'am, 6A square.
Again, louder.
6A square, ma'am.
6A square. 6A square or 6 into edge square. So 6A square. This is the original surface area because the edge is A. 6A square units. The new surface area will be 6 times edge square. See children, it is 6 edge square. 6A square. Whatever is the side or the edge, whatever is the edge, you should square it, and 6 times that is the surface area. 6a square. So 6a square. What is a now? The new side or the new edge is 2a.
2A. Yeah.
Yeah, 2a. Original surface area is 6a square. New surface area is 6 times edge square. So 2a the whole square. 6 times 2a the whole square. So it becomes 6 into 4a square or 24a square. 24a square. So original surface area is 6a square. That becomes 6a. How will 6a square become 24a square when it's multiplied by 4? How will 6a square become 24a square when it's multiplied by 4? 24a square. So the surface area will increase 4 times. 4 times. You can express 24 as 4 into 6a square. 4 into 6a square. So this is the original surface area. 4 times that is the new surface area. Yes, children, please write down. Read the contents first. I'll give you some time. Read what you see on the screen and then start writing. You can write original edge of the cube. Original edge of the cube. Okay.
Finished, ma'am.
Okay. So if the
Just a
it's
minute.
very easy, children. See here, if the edge is A, then the volume is A cubed, and the surface area is 6A square. If the edge is 2A, let me take some more space to write it. 1 minute. I'll do it here. If the edge is A, volume is A cube, surface area is 6A square. If the edge is 2A, then the volume is 2A the whole cube, which is 8A cubed. And the surface area is 6 times 2A the whole square. 6 edge square. That is equal to 6 into 4A square, which is 24A square. Now compare. A cube becomes 8A cube. So volume becomes 8 times. A cube becomes 8 into A cube. So volume becomes 8 times. 6A square becomes 24A square. So 6 into 4 is 24. So surface area is 4 times. The new surface area is 4 times the original surface area. The new volume is 8 times the original volume. Is it fine, children?
Yes, ma'am.
Okay.
Ma'am, can you show the answer slide?
Yeah.
Completed, ma'am.
Yeah. Was it easy to understand?
Yes, ma'am.
Devadarshini and Kirtana? Any
Yes,
questions?
ma'am. No, ma'am.
Okay.
No, ma'am.
All right. Now, if the edge of the cube is tripled, then answer the same questions. If the edge of the cube is tripled, that is if it becomes 3A, then find out how many times the volume and surface area increase.
Ma'am, volume will be 27A cubed and the surface area will be 18A squared.
No, not 18A squared. You're right with the volume, not surface area. You tell me for the volume, Kirtana.
Ma'am, so basically area of, volume of a cube is A cube, ma'am. So if the new edge is 3a and then 3a to the power cube, ma'am. So 27a cube, ma'am. The new volume is.
So the new volume is how many times the original volume?
Three times the original volume.
What is the original volume?
A cube, ma'am.
What is the new volume?
Sorry, 27 times the original volume, ma'am.
Yeah, the new volume is 27a cube. So the new volume is 27 times the original volume. What's the original surface area?
6a squared.
What's the new surface area? 6 into
3a squared.
what's the answer?
18a squared.
What is 3 square?
9, ma'am.
9 6
54.
So it's like this. Six into 3a the whole square, 6 into 9a square, 54a square. 6a square becomes 54a square. 6 into what is 54?
9.
9. So 54a square is actually 54a square is 9 into 6a square. 9 into 6a square. So the new surface area is 9 times, not 54 times, 9 times, because original is 6a square. New is 9 into 6a square, 54a square. So it's 9 times the original surface area. The new surface area is 9 times the original surface area. Correct? Children?
Yeah, ma'am.
Yes,
Okay.
ma'am.
See, you can express here also in this answer. So 24a square we get, right? So what is this 24a square in terms of 6a square? 6a square 4 times. You write it in terms of 6a square because original is 6a square, right? So 6a square how many times? 4 times is 24a square. So that's how we say that the new surface area is 4 times the original surface area. Because original surface area is 6a square. The new surface area is 24a square, which can be expressed as 4 times 6a square. 6a square, 6a square, 4 times. So the new surface area is 4 times the original surface area. Water is pouring into a cuboidal reservoir. Water is pouring into a cuboidal reservoir at the rate of 60 liters per minute. Water is pouring into a cuboidal reservoir at the rate of 60 liters per minute. If the volume of the reservoir is 108 meter cubed, find the number of hours it will take to fill the reservoir. Now, Raja, tell us how will we convert 108 meter cube to liters?
Ma'am, 1 meter cube is equal to 1 kiloliter or 1000 liters.
This 1000 liters.
Yes, ma'am.
Then
108 108 meter square means meter cube means 108
No,
into
then is equal to X liters.
X liters. Sorry.
Now
X
cross multiply.
1 meter cube into
What is X into 1?
1 X man.
Is equal to what is 108 into 1000?
1,08,000. 1,08,000
liters, correct?
Yes, ma'am.
Now, so the capacity of the tank. So children, it's see, we'll just take it like this, okay? Supposing you can fill, supposing, you know, it's like 1 liter or 2 liters is filled in 1 minute. 2 liters is filled in 1 minute. Suppose you have to fill 60 liters. How many minutes will you take? Supposing to fill 2 liters, you take 1 minute. 2 liters, you take 1 minute. To fill 60 liters, how many minutes will you take? 2, 4, 6, 8, 10. Okay, this is okay, not easy to understand. Fine. For 2 liters, you take 1 minute. For 4 liters, how many minutes will you take? To fill 2 liters, you take 1 minute. To fill 4 liters, how many minutes will you take?
2 minutes, ma'am.
2 minutes. To fill 8 liters, how many minutes will you take?
4 minutes, ma'am.
4 minutes. To fill 12 liters?
6 minutes.
6 minutes. Similarly here, 60 liters is filled in 1 minute. Then 1,08,000 liters will be filled in how many minutes? That's all. First convert 108 meter cube to liters because one volume is in liters, the other is in meter cube. So have both in meter cube or have both in liters. See, this is also a unit for volume. Meter cube is also a unit for volume. Both are units for volume. We won't say 1 liter is the length of something. 1 liter is the length of something. No, liter cannot represent length. Liter is volume. Meter cube is also volume. Have both in the same unit. So what we do is we convert 108 meter cube to liters and we get 1,08,000 liters. Now it's like this, 60 liters is filled in 1 minute. So that means 120 liters is filled in 2 minutes, which means oh my God, 180 liters is filled in 3 minutes. 240 liters is filled in 4 minutes. 300 liters is filled in 5 minutes. Then 1,08,000 liters is filled in how many minutes is what we have to find. So in such cases, a proportion will help you. See, because sometimes you might, get confused. You may multiply instead of dividing. You may divide instead of multiplying. So this proportion will save you from all that mess. See here. So see here. First, 1 meter cube, 1,000 liters. 108 meter cubes, how many liters? So that is, we are converting meter cube to liters. So the volume of the reservoir is 1,08,000 liters. Now, 60 liters is filled in 1 minute. Then 1,08,000 liters is filled in how many minutes? So again, product of extremes is equal to product of means. See, here you have to divide. 1 minute. I just missed one step here. So meaning for you to understand, I think I can put one more step here. So let me work it here for you. Take it. Yeah, please write along with me, children. Divide this by 60 to convert it to hours. So children, the first step is you convert the volume of the reservoir, which is in meter cube, to liters. So you can see that proportion there. 1 meter cube, 1000 liters. 108 meter cube, how many liters? X liters. You should have the same units in the numerator, meter cube, meter cube. Same units in the denominator, liter, liter. Cross multiply and work this. The answer will be in liters. Next, again, another proportion. 60 liters is filled in 1 minute. Then 1,08,000 liters will be filled in 5 minutes. So we have liters in the numerator and minutes in the denominator. Cross multiply. And y you get is 1,800 minutes. Why minutes it is? Divide by 60 to convert it to hours. So 3 hours. That means the reservoir can be filled in 3 hours. Understood, children?
Yes.
Okay.
Yes.
Completed, ma'am.
Completed, ma'am.
Good.
Completed, ma'am.
Followed. Yes, we finished volumes and surface areas from NCRT. Get this question, children. Take down the question. Yeah, do this. Children, I think I wrote 3 yards, right, by mistake. Nobody told me it's 30 yards. 1,800 minutes divided by 60. I erase a slide. It's 30 yards. You've written 1,800 by 60 yards, right? 0 gets cancelled and then 180 by 6 is 30 yards, not 3 yards, 30. Okay, answer this one, children. No, this is very simple.
Ma'am,
Yeah?
I got it, ma'am.
Yeah, tell me.
So the lateral surface, yeah, ma'am, the lateral surface area of the cube is 16 square.
16 square. Huh?
Yeah, ma'am.
Explain your steps.
So volume of cube is A cube, ma'am. So A cube is equal to 64 centimeter. So A is equal to cube root of 64, which is 4 centimeter, ma'am.
Okay, this is correct.
So one edge of the cube is 4 centimeter, and the lateral surface area formula is 4A squared, ma'am.
Correct.
So 4 of 4A, ma'am.
Yeah.
Sorry, 4 of 4 squared, so 16 square.
No, this is what I don't know. How is it 16 square, Kirtana? What is 4 square?
16, ma'am.
16 into 4. The square is only for 4. 4 into 4 square. How do we simplify this? 4 into 4 square. You cannot multiply 4 and 4. The square is for 4. So you need to simplify this first. 4 square. Simplify this. What is 4 square? 16. 16 into 4 is 64. So it is 64 centimeter square. You're right, but the last part.
Okay,
To simplify 4 into 4 square, 4 square should be simplified first. 16. 16 into 4 is 64 centimeter square. You're right, Kirtana. Very good. So first you need to find the edge of the cube and then the lateral surface area. Next one. How many small cubes with edge 20 centimeters each can be just accommodated in a cubical box of 2 meters edge?
Ma'am, I got the answer, ma'am.
Tell me.
1,000 cubes, ma'am.
1,000. Yeah, read out the steps from the beginning.
So I converted the 2-meter edge of the box, no ma'am, the cubicle big box, into
Correct.
200 centimeter.
Okay, correct.
So number of cubes that can be accommodated is equal to volume of the cubicle box divided by volume of small cube.
Very good, very good. Number of cubes that can be accommodated is equal to the volume of the big one, volume of
cubicle
the
box. Yeah.
Cubicle box divided by
volume of the small cube.
Volume of one small cube. Very good. Volume of one small cube. Good.
So 200 into 200 into 200 by 20 into 20 into 20.
Very good. Very good.
And then when I simplify it, I got 1,000.
Very good. So volume it is. You should not do. It is not 200 by 20. It is not 200 by 20. It's a volume of the cubicle box. 200 into 200 into 200 by volume of one small cube. 20 into 20 into 20. So 20, 10 times everywhere. 10 times, 10 times. And Kitna, you're right. So 1,000 cubes can be accommodated. Very good. 1,000 cubes can be accommodated. Is it fine, children?
Yes, ma'am.
Okay. All right, children. So that's it for today's session. So looks like this will be our last session for 8th standard. Share your timetable with me. Don't forget, please do that at the end of the class. Meaning, as soon as you leave the meeting, please share that with me. Your timetable, portions, and the list of chapters that have been covered in your school. All right?
Okay, ma'am.
All right, children.
Okay.
All right, children. So that's it for today's session. Thank you. Good night.
Thank you.
Thank
ma'am.
you, ma'am.
Yeah.
Ma'am, I'll send within today, ma'am, my timetable and all other things.
All right. Yeah.
Yes, ma'am. Thank you, ma'am.
Thank you.
Thank you.
Thank you.